Hello, everyone, and let me. Oh, I've already screwed up. I can't get. I should turn that thing off. Hi, welcome to TGI. Let me figure out how to turn off the starting soon. That's great, isn't it? There we go. Right. Hi, I'm Nadir Jiwa, as ever. We're going to be looking at Karpenter with Marco. Hi, Marco.
Hello there.
Hi. So, do you want to introduce yourself?
Yeah, absolutely. First, thank you for having me. My name is Marco Beltz. I work as head of consultancy at the Scale Factory. We are AWS partners, and we work in the AWS space and also tightly kind of with containers and containerized workloads, where we help our customers to kind of achieve more in their cloud workloads. So yeah, that's me.
Cool. And if you're not familiar with who I am, I've been working on Kubernetes Cluster API for a long while for AWS. And full disclosure, me and Marco used to work together. And we will be talking about Karpenter because Marco's presented on Karpenter a few times. So bringing on as a subject matter expert. And I'm currently an engineering lead for Tanzu Kubernetes Grid at VMware. Let's see who's around. Happy Friday all from Israel, from home. Thanks. Happy Friday to you. Hi, Martin from the Netherlands. Walid from Saudi Arabia. Egypt. Cool. So as ever, our first thing. Oh, I should post a link to the notes. The notes are going to be at notes 1. Let's check that's okay. Yep. That's the notes. So feel free to edit in real time. So the first thing we are gonna do is our week in review. If I can find the correct things now, the banners, that's the right one. So there we go. All right, let's. So first things first. In week in review. So from Kubernetes, we've had a couple of new patch releases. One thing that's happened in the last week is Docker shim support's been removed. I probably should share my screen. Let's do that. Hold on. Let's there we go. There we go. So Docker shim support was moved from kubeadm. Now, some of you might remember the sort of semi-controversy around this when it was first announced about a year ago, I think, that this was going to happen in the Kubernetes project. And there was a lot of confusion around what that actually meant. So don't panic is the answer. So Docker is not going to go anywhere. You can still build your containers using Docker. And what we mean by this is using Docker on its own as the container runtime for Kubernetes is going to go away, and mostly in favor of using containerd actually for most. What this means for most people, which Docker ultimately uses anyway. So really, nothing really changes. It's just we're just removing one of the middle people, I guess, in between, like containerd and Kubernetes. So don't worry, we're still expecting people to use their favorite tooling to create images. So just in case you might see that and you panic. So what else? So just notice in the CNCF sandbox, we had a new project join, and that's devfile.io, which I've not seen before, but I think this is around. I don't know if you. What was the equivalent back in the Docker days? What was it? There was that method of running. You had like a YAML file, and it would run a bunch of Docker containers, and you stick it in your repo. Who remembers that? I've totally forgotten. Jesus. Anyway, it's a replacement for that, and also I think it's also a bit, from what I've seen, it's a bit like tilt.dev, so which is something I've used a lot. the tilt, we're using Cluster API. It's a mixture of actually of using Starlark. Compose, that's right. Docker Compose, that's the one. Yes, so this is kind of like Docker Compose. And I think there's been a couple of other similar sorts of projects as well. So it's another one in that space. So it's joined the CNCF sandbox. People are interested, we might do TGI on this, might give it a spin, find out what it's all about. One I'm really familiar with is Tilt, which uses the Starlark language, and we use that a lot in Cluster API. And it says Compose is very alive. You can push from Compose to ECR or AKS. Yeah, thanks for that. I stand corrected. Yeah, cool. Is there, and if you haven't seen, please don't all just sort of start watching this instead. Like, I know, like, YouTube short attention spans and all, fickle viewers. It's not like we've got the sponsorship spots. Not going to do any. Here we're sponsored by Skillshare or Brilliant.org or anything like that. So you can stick around. But the Kubernetes documentary is just out. The first part was just premiered earlier today. I haven't seen it yet. It's got a lot of the founders from Kubernetes. Suggest everyone watches it, but not right now. Okay, later. All right, so today we're going to talk about Karpenter, which has been on the horizon for a while now. I've certainly had some conversations with AWS around this previously, talking about how we might use it in Cluster API. But yeah, it's I think they did a formal announcement at reInvent, was it? I think possibly.
I think it made it the GA at the reInvent, but the first time that kind of piqued my interest was, I think it was KubeCon Europe, KubeCon EU. So yeah, must have been like almost a year ago now. So it was already in kind of 0.3 version, but still quite early stages. So they kind of pushed it through and made it to GA 0.5. And this is kind of the currently latest stable release that they're using.
Yep. Thanks. And it's here where I reveal, as far as I'm concerned, there for myself, the emperor has no clothes. So I do not run Kubernetes in production. Personally, I develop on the Kubernetes project itself, but as far as I don't use it in production much. And actually, for the last couple of months, I've been doing design stuff and other bits, so I haven't actually used Kubernetes for ages. So this is going to be fun, isn't it, as we play around? So I think the way I'm going to play this is revisit Cluster Autoscaler, basically. As you're probably people are sick of me going on about, I'm from the Cluster API space, so I'm going to redeploy Cluster Autoscaler with Cluster API, and then we'll take a look at that and go through the shortcomings, and then we'll switch over to Karpenter on EKS for reasons that I'll get into later, and yeah, and go through what the differences are, why we might want to support Cluster API using Karpenter. Yeah, just get some ideas, see what that's about. Don't know. Yeah. Does that work for you, Marco?
Yeah, so sounds good to me. Definitely sounds like a good plan, and quite interested to kind of see where that leads us today.
Yeah. Thank you, Valid, for dropping a link. So there was a talk. The talk that Marco mentioned was from Ellis Tarn and Pratik Kujia from Amazon in KubeCon EU 2021. Yeah, it was Ellis that I had talked to previously about this. Yeah. So, all right. So if I go to my terminal, so I have spun up both clusters. I will just close it. So I've got EKS cluster, which has spun up with EKS Cuttle. In the background, if I just go back, For those who don't know how Cluster API works, Cluster API uses Kubernetes itself to deploy clusters. So I had kind Kubernetes in Docker. Hi, Vlad. Hi, Ellis. Thanks for joining. All right, so I might throw you a link, Ellis. I might get you on. That's what.
No pressure there, Nadir.
Yeah. Yeah, I might. All right, so so I've got a kind cluster. So that's Kubernetes in Docker. It's a bit like using Minikube, in which cluster API is running. I defined a cluster which is called TGI K182, and I can probably do this one. Cluster. There you go. So it's made up of an AWS cluster API cluster using KubeADM control plane, which is kind of defaults around cluster API. We have a bunch of machines. We have a machine deployment, I think. Which has probably want to give it some replicas. So machine deployments are like normal deployments, except we're scaling machines instead of let's just do one for now, instead of pods. So we're just going to create one machine. This might give you an indicator of how Cluster Autoscaler is going to work. Right, so that's doing its stuff. We have this is the EKS cluster. Did it deploy a CNI? I haven't. No. AWS, no. I assume that's. I'm sure it runs a VPC plugin. I don't know. Yeah, it must do. There's probably some components which are running on the control plane. I assume it is, so I'm just going to do that. I've not used EKS before.
I think the CNI comes with the AWS node deployment, so it should be all right.
Yeah. Wait, I'm just taking off that week in review banner as well. Right. And we have this cluster, and I think I deployed a CNI to it earlier. Yeah, so we're running Antrea. Oh, it's in. Oh, yeah, because we just spun up the new node. So that's doing it. Cool, fine. That will settle down in a minute. Right, so we need to deploy Cluster Autoscaler on this. So instructions have changed since I last looked at this, which was probably about 18 months ago, which is kind of ironic because I was temporarily a reviewer for this. Probably shouldn't have been. Yeah, so I was formerly a reviewer for the PRs that were coming into the Cluster Autoscaler Cluster API provider. Right, so I think when this first started, you had to run 2 copies of the Cluster Autoscaler, one in your management cluster, one in your actual cluster. Today, you only need to do it in the one place, and that's because we can set this setting. So we're going to actually run the Autoscaler in my kind cluster on my laptop. So in production usage, you're going to have one permanent management cluster, which is probably going to be in AWS, and that's going to manage lots of other clusters that are created underneath it. And you would just install Autoscaler on that. I've not, and there is a process in which you can move resources from your local machine over to a newly created workload cluster and convert to management cluster. We're not going to do that today because it's a bit of a pain. There are tools to. There is a cluster. Actually, we could do it. Well, not going to tempt fate. There is a cluster cuttle move command. Yeah, it's only a pain because I can't be bothered to grab the kube config and pass it into the flag, but it's straightforward enough. Basically, if I did this, it would convert that cluster that I've made into its own self-managed management cluster, and we'd run it all together. But for the purposes of this, and to sort of simulate how you would do this for real, we're going to pretend that my local Docker based Kubernetes cluster is a permanent management cluster, and that's the way you would run one autoscaler that manages all of the other clusters. So hopefully I have got this manifest properly. So I took the examples saying it's just going to create a cluster autoscaler namespace, going to stick a deployment in it. We're going to set the setting that's needed. Bunch of cluster role bindings that allow it mostly that can that can watch the relevant cluster API resources, which are machine deployments and the scale sub resource, machines and machine sets. So yeah, so that's pretty much it, and hopefully that works and I haven't screwed up networking, which I did 35 minutes ago. Right. Okay. Also, because I was just in a bit of a rush. Going to yeah, so I was just going to deploy. I already have that workload, so just going to... VH has a nice little demo, so I'm just going to use it. Also, I do. These are not permanent clusters, so right. So let me. Okay, one thing I need. Please watch out and tell me off if I'm going to the wrong context, because I've done this like 5 times already today, deploying things into the wrong place. Right. Okay, we will do the same thing on EKS cluster as well. Okay, all right. Right, let's go back to kind. See how bad my internet is. Wait a minute. Oh, I didn't deploy the cluster autoscaling wrong. I did deploy in the wrong. Oh dear, already. It doesn't matter. Like, I mean, basically what's going to happen, well, if we have a look at what's happening on that other cluster, probably having a bad time, I think is, yeah, there we go. It's in crash sleep. We can have a look at what's why it's in, and it should be pretty, yeah. Yeah, I'm not convinced that the output of this is particularly helpful today, but once you do scroll all the way up to the top, it is fairly obvious. So I think probably something in maybe opening issue in the cluster autoscaler repo to not spew out millions of debug lines for the error, which is this. It could not find the cluster API resources because they're not deployed in this cluster. Right. Right. Let's get rid of it. Okay. So that's working correctly. That's running. All right, cool. Oh yeah, now it's confirmed. Yep, we're using the AWS node is the CNI. Cool. Oh, that's the one where it sets up routes and everything uses. Right. Yeah. Okay. I think. Right. Okay. So got that running. And other next Emperor has no close thing. I've never used class Autoscaler, so that's fun. I guess technically a VMware project since VMware bought Heptio. Which project are you talking about, Andrew? Do I need to tell anything about? Do I need to tell Cluster Autoscaler what it's allowed to scale and what it isn't, or does it just do it?
I think it should just do it if it has enough permissions.
Okay.
I'm just thinking if cannot remember if there are any tags you need to kind of put.
Yeah, I'm just wondering about that actually. So enabling that. Yeah. So I need to edit those. Yeah, fine. I thought so. That makes sense. So I need to put those on the machine deployment. So, all right. So on the cluster autoscaler. Oh, KTX. Yes, that's right. Yeah, I don't know if that counts as a Heptio project. I think that's more or less just someone at Heptio did that. Yeah, Vlad's goes Autoscaler does have auto discovery, but it needs certain tags. Yeah, it's these ones. So, so on this cluster, I've got a machine deployment, and I had already manually scaled it to 1 earlier. So it's so slow. It's weird. Anyway. And the way this works is this machine deployment is linked to an AWS machine template. So that's really going to define it's one instance type. So I think I configured it as t3.xlarge much earlier. Yeah, so it can spin up a number of T3 xlarges. These specs I forget, but I just pick it because it sounds like it's not going to crash. So I just don't. No, we're using an upstream CI as that value. This is why I use that one. Or you might be using 2x large. I'm not sure. I know it's not so small that once you deploy like CNI and stuff that it doesn't just start falling over. Right. So we're going to add the metadata, which let's go back to the docs. I need this one. Annotations. One, I guess. It's max size. 10, I suppose. I think I'm almost certainly. I think I've got enough source quota in my AWS account for about 200, so that should be fine. Okay, I think that's it. So I'll save that. Wonder if there's any logs that come on. I didn't. Why is it not doing that? I should just use annotations. Oh, it needs to be a string. Oh, every time. Done that so many times. All right. Couldn't find template for node group machine deployment. Ah, interesting. Do I have that in the docs? No. I don't know why it's saying that. Maybe I have to add. That is a string. Stop complaining. Restarted that pod. Maybe that's what it needed. Yeah, Valley said, I guess one of the advantages of Karpenter versus Caster Autoscaler is less configuration. I don't know.
Probably a fair point, but yeah.
We'll find out, I guess.
Yeah.
All right. It's still complaining about couldn't find a template for the node group, but we'll leave that. I don't know what static autoscaler.go is, but maybe it's just maybe. Oh well, we'll just ignore it. We'll see what happens. Right, so we put some annotations in there. So we have our workload. We need to now go to the actual cluster. Okay, so this has got 3 replicas. It's got a bunch of resource requests, which are well within bounds at the moment. And what is a t3.xlarge when it's at home? I still use this site. What's cooking? I just joined. Yeah. Karpenter versus Autoscaler. That's pretty much it. So also I pretend I know how to use Kubernetes. It's large. It's 16 gigs of RAM, 4 vCPUs. So if I want to scale this, let's give it a bigger request. So we can reason about it more easier. That sound reasonable, Marco?
1G, you mean 1?
Let me just do 10.
Oh, wow. Oh, you're really going for it. Okay, yeah.
Oh, no. Oh, whoops. Doing the wrong thing. CPUs. Let's do 10 GI. So actually, hope. Well, that's already. Well, it's already running 3 replicas. Let's maybe give that 4 then. And it didn't like it. What did it like? Oh. Okay. Starting those up again. Hi, Justin. Thanks for joining. Yeah, Carlos, we'll get to that. Any additional providers in the wild? Yeah, so as far as I know, it's only AWS. Yeah. Vlad, I always have to relearn these things too. Everybody does. Took me literally 10, 15 minutes to figure out how to get a CRD without autocomplete and just typing random things. Yeah, that's pretty much my my everyday. Right, so that's all no real change there. But if we were to, I guess, try and scale this to 10 now that we've got requests up, that should be well beyond the bounds. We got pending. Now, if I don't, there was a Twitter thread about this. Don't like don't like the kubectx changing between shells. I believe a few days ago. So still only let's have okay. Still complaining about the missing template.
Trying to think why it's complaining about that.
Right, so we connected it with that version. Use specify kubeconfig for workload cluster. Is that what I'm missing? Could be. I don't think I needed to do that. Oh, okay. So it's still. Right. So it's a single instance of the cluster. It is still a single instance of the cluster autoscaler per workload cluster. Right. So on this client instance, I have a bunch of secrets. One of those secrets is actually a kubeconfig. So I need to join that in. Right. So this also means that this needs to be deployed in the default namespace because that's where the cluster is. Right. Okay. Let's do that. I was already messing about with that. I had misread the docs once. Right, we've done that. Okay. Now, well, you can mount a secret here. When I get all the syntax.
That's usually the tricky bit, right?
Let's go to docs because I know it's there. There's that one. What's the name of the secret? Right. This one. That's the kube config. Oops, that needs to be secret name. Then we need to put a mount in here. And we need to give this a kube config, TGI K183.value, I think is what it is. Right. Capital P. Hopefully we'll stop complaining around about that missing template. Nadir, question valid. Are you following the AWS cluster autoscaler provider? No, I am following the cluster API provider for cluster autoscaler, which is supposed to be infrastructure agnostic. It does come with some limitations. It means there's also I want to look at Karpenter because the cluster API autoscaler doesn't know about things like what instance type it is. It doesn't know if it's doesn't know like if it's got GPUs or whatever. So there's actually quite a lot of limitations about the cluster API provider for cluster autoscaler, but it is somewhat infrastructure agnostic. So it's not going to create any autoscaling groups on its own. All it's going to do is change the value. I think it's already done it. So it's already scaled that the machine deployment for, and then we have a this controller, cluster API AWS controller, is the thing that is scaling which is creating EC2 machines individually. So it's doing it one by one. So it creates a new EC2 instance. There's a whole bunch of things that happen where it generates temporary credentials for that new node to then join the Kubernetes cluster. There's a bunch of stuff that happens, but so cluster autoscaler's only interface is a hook into the workload cluster to be able to monitor like pods that are waiting to be scheduled, etc., and a hook into the management cluster side to be able to scale machine deployment resources. It doesn't need any other credentials than that, so it operates on its own. So I don't have to do anything with IAM beyond what I've already given to cluster API. That makes sense. But yes, so we have that. So I guess now is where we start getting in. If I were to increase the requests to something that a T3x large isn't possible, I think I'm now going to run into a problem. Is that right, Marco?
Yep, I think so. So if
right.
you're going to try to scale it up to something that's not going to fit, I think we're going to end up in an interesting situation. Yeah.
All right, let's do that. Let's get rid of some of these temp files. Right, I'm going to get rid of that. We've finished touching the... So, oh, we edited it in place. Okay. Oh, well. Oh, back in there.
Probably need to switch context, right?
Need to switch context. Oh, I'm not. Why am I editing? I need to edit a deployment, not a machine deployment. Okay. Right, now we got the right thing. So we have 10 replicas. So if I were to say, I think it's 16 gigs of RAM in total for T3.x large. So if I were to say this is actually 32, now I'm going to run into problems.
Not being modest here, huh?
So now these are all 10. Well, is it slowly terminating everything?
Well, they should end up in a pending state, right? Because they cannot be scheduled until the the nodes are available.
Yeah. Yeah, slowly. Yeah. Okay. Okay, yeah, it's slowly. Oh, yeah, because it's trying to roll through them. Oh, that's not really helpful, is it? So what we're going to see is a bunch of pods pending. And a bunch of them will still be running because it's not going to get rid of the old ones until it's had a chance to see these running, which it's never going to do now because we can't. So if we were to do a describe on that, there we go, insufficient memory. So now we're stuck. So nothing we can do here. And there's nothing Cluster Autoscaler can do as well because it doesn't have knowledge of different instance types. Yeah.
Yeah, it only knows how to scale up the same type of instances. So if you end up trying to schedule a workload that doesn't fit the instance type, you're kind of stuck, right?
Yeah. Now what we could do, maybe we could get. Well, let's now. I guess so. Karpenter will solve this problem for me, right?
Hopefully. We're gonna see. Well, I'm saying it's gonna solve your problem, but yeah, let's not get ahead of ourselves.
Okay, right. So let's leave Cluster Autoscaler for a moment. I'm interested in coming back to it maybe later. So I think we can stop switching between multiple contexts as well because we're going to go to this EKS one and only this EKS one. Now we don't have a management cluster or whatever. To be fair, I could have provisioned an EKS cluster through Cluster API as well. It's just there wasn't really any point. I wouldn't see a situation where you run. Well, maybe you might. I don't know. Would you run a cluster? You might still use Cluster Autoscaler on EKS with Cluster API, possibly. Yeah, it would work. Yeah, so we are going to deploy Karpenter on this, which when I last looked at the instructions, did you want to give us a little intro in why Karpenter exists?
Yeah, sure, absolutely. So as we've seen with the cluster autoscaler, one of the reasons why you probably want to go with something else rather than cluster autoscaler is exactly the reason we've seen. So if your workloads don't always kind of match the resources you have, this is obviously one big limitation with cluster autoscaler or similar solutions in this space, right? So it's not just the cluster autoscaler. Probably worth mentioning the reason why we showed you the cluster autoscaler, because this is kind of, let's call it a de facto kind of autoscaling solution out there, or at least the solution that's most popular at this point. But in case you're adding things that don't fit, the cluster autoscaler can help you. And this is where Karpenter kind of comes in, where the scaling, it's also called like a nodeless autoscaling. And the reason why it's called like that, because it kind of eliminates the whole concept of node groups. So instead of scaling in a way that you have node groups where you would add like identical identical resources to it, identical nodes, it literally works on a different level. So it eliminates that concept and kind of try to provision resources for you outside of that, and then help the scheduler to kind of efficiently add those resources in your cluster based on the workloads you're trying to schedule. And there are other kind of advantages as well. So the speed is a big advantage as well. So with the cluster autoscaler, right, you need to wait until your in AWS autoscaling group figures out, oh, I need to scale up. It adds instances in. So all that kind of procedure can take up to maybe 3 to 5 minutes, I guess. Depends on the... Oh, thanks, Dom. Yeah, the node group is a concept in the EKS. Yes, correct. But it's implemented with using autoscaling groups, which, like I said, it can take up to 5 minutes to kind of provision your resources based on what you're requesting, which region and other bits. Whereas with Karpenter, it's actually using that direct API access, and it's using, I think it's the API call that's using its create fleet. And that literally requests a fleet of resources for you using the API calls. And they're probably spun up in the quickest way possible, I would say, that you can actually get those resources available from AWS. And as they're being provisioned, Karpenter also ensures that those resources are being bootstrapped and automatically added to your cluster as standalone nodes. And it works in collaboration with scheduler, where it kind of indicates to the scheduler where those pods needs to be scheduled, right? So it doesn't wait for resources to be available before it relies on scheduler to kind of figure out where to go, but it kind of predetermines that using, I think it's actually marking pods using the kind of node annotation. So it kind of annotates the pods where they need to go. So the whole thing kind of happens in a time span of usually about a minute. I think the good friends at AWS have kind of a really good ambitious goal to bring that up down to 10 to 20 seconds, if I remember correctly, which I'm actually looking forward to that. I think that would be really an improvement. So that's one of the kind of the problem spaces that is solving. And the other one is probably, for example, if you're using things like cluster autoscaler, you're also limited in a way where your nodes would be provisioned to. So it will automatically, it will just pick a random region where the next node would be kind of added to. Whereas, for example, if you're using persistent volumes, that might actually be provisioned in your cloud provider, such as AWS, in a different region where you're getting the nodes to, right? So you can end up in a situation where you're provisioning nodes, but the pod still cannot be scheduled. Whereas Karpenter is a little bit more intelligent there.
You mean AZ, right? AZ,
not region, AZ, yeah. You guys right, yeah. So the AZ, where Karpenter actually provisions the nodes in exactly the same region where you actually need it, which is also a big advantage there. And like we mentioned before, the nodes that you're getting are actually the right size. So with the cluster autoscaler, you would always end up with the same type of nodes that the original autoscaling group or the template was used. Whereas with Karpenter, it's actually using, I think they're calling it like a really fast kind of controller that kind of, it's using a bin packing algorithm that kind of tries to figure out and kind of figure out which resources can actually provision in order to fit all the specific pods that need to schedule. So it would actually use the optimized instance size that would satisfy the need for scheduling your workloads, which is also kind of cool as well. So obviously it will provision the nodes from the list that you provide, but at the same time it would pick the optimal one for the specific need that you have at this point. So, for example, if you need to provision a single pod, you might end up with a really small instance. If you have like a large amount of pods or a huge one, like Nadir showed us before, right? So if you kind of really bloat it up, it would try to provision an instance that would satisfy that requirement, which is also kind of cool.
Cool. Thanks for that. Ellis is saying Karpenter has a full scheduler implementation at source. Scheduler is only in the loop when capacity already exists. Okay.
Right.
And there's some questions about Azure. Yeah, so Azure uses VM scale sets. You kind of have to do it in Azure as well, because so there is a difference in. Actually, one thing I like about Azure, not too good to be honest, is like you can put everything in a resource group. You can also hit delete on a resource group, and everything goes along with it, which is really nice when you want to clean up. You don't have to use tools like AWS Nuke and stuff. Now you can kind of use the resource tagging API to do some of that now, but one of the limitations around resource groups in Azure, however, is that there is it's like some weird number. Like you can only have about 834 resources in it, or something. It's some weird limit. Anyway, every VM counts towards that limit.
Right.
So if you want to do a large cluster in Azure, you absolutely have to use VM scale sets. And from a cluster API perspective, that's implemented in using something called a machine pool resource, which I don't think the cluster autoscaler quite yet supports, because there needs to be additional information for the cluster autoscaler to figure out what the machine type is and whatever. So I think today, what happens is cluster autoscaler on the cluster API context determines the size of an instance by looking at the machine deployment, looking at the AWS machine related to the machine deployment, going into the workload cluster, getting the information from the node, and then inferring that all of any node that would be created as an additional replica in machine deployment would have the same like memory or CPU capacity. But because the machine pool can go down to 0 or something like that, you lose as soon as you've got the option to scaling from to 0, we lose all that information. So there is a design document in the cluster API project to give more information around how that would work, and then that would allow ASGs essentially to work with cluster API. But cluster API based cluster autoscaler today does not use autoscaling groups or VM sets. It lets cluster API create machines on its own. There's a question from Shengwin. Can the user customize the node size and type to optimize the cost?
Oh yeah, absolutely. We're obviously going to see it kind of more a little bit better as we go through the example, but there is a concept of provisioner, so which is defined through the CRD, and in the CRD you can actually define a list of instances that you want to provision from. So you can actually limit it down to a certain set of instances that you're happy to have provisioned. And obviously, when you're provisioning workloads, they need to fit into those kind of instance sizes. But yes, that's the thing you can do. I would just like to go back to, I believe Alice posted in comments as well, that actually has a full schedule implementation in its source. What I really like about Karpenter comparing to Cluster Autoscaler is it's completely decoupled from the scheduler. So for example, if you're using Cluster Autoscaler, you actually need to use the same version than the Kubernetes version that you're currently running it on. Whereas with Karpenter, it's completely decoupled. So it's not really using any of the kind of dependencies on the scheduler itself, which is quite nice. But at the same time, it is working quite closely together with the scheduler. So you get all the benefits, but you're not really dependent on the versioning. So that's really nice.
Yeah. I didn't realize that was the reason why the Cluster Autoscaler is so tightly coupled to the Kubernetes version. It's certainly been a pain for us in terms of it's just yet another dependency that we need to think about when we're like from a vendor perspective from like versioning all the components. It's yet another one we need to take into consideration whenever Kubernetes gets spun. I didn't realize it's because of the scheduler in particular, the scheduler code being imported, etc.
Exactly. And for example, I was just looking at one of the issues. I think it's a well-known issue on the, I think it's AWS provider, when you want to scale down to 0. There are some kind of rough edges around there, and there is an issue opened. And even though it's going to be merged, for example, the way how the merging process works, it's going to be merged in the next version of Cluster Autoscaler, which is 1.24. And it's even going to made it in 1.25 or something like that to the EKS, which, you can imagine that the release cycle is quite long if you're waiting for a feature that will make it to your EKS cluster. So,
yeah. All right, I guess we'll try and get this going, I suppose. So we have that. Right, we need to create an IAM role. Apparently.
Yep.
Yeah. Okay. Let's try YOLO that. Let's have a look.
It's fine.
I'm sure it's fine, but let's be sensible.
Maybe there's some Bitcoin mining in it, but it's fine, right?
Right. I can finally get my Hexagon Twitter profile, I suppose. All right, so it's all looks reasonable. It's gonna, we're gonna have the fleets and the run instances and terminate instances and stuff. So, okay. Does it always use is there a case where it might use the run instance API instead of fleets?
I think how it currently works, it just provisions using create fleet. I believe if I remember correctly from the initial talk that was posted before in the comments, it was explained that they were kind of contemplating between one of another kind of API call. Basically, they're literally the same thing. So they just decided to go with the fleet, but it should offer the same functionality.
We're done with the docs. Okay. Let's keep this PG. Okay. Did I swear? I don't think so. All right. I don't really care, but I don't really care about the variables. Cluster name. Right. All right. Let's be sent. It's Amazing Badger, apparently. I did not choose that name. That's just one randomly generated by EKS Cuddle. Catch you guys later. Yeah, all right. Thanks, Ellis, for joining us. Thank you. See you later.
See ya.
Oh, is that temp outfit? Oh, MK. Oh, okay, fine. I guess if I had pasted that in one go, that would have been fine. But anyway.
Yeah, it's just creating a temporary location locally. I'm just going to remove it after it's done.
Okay, I've not used eCurse Castle, but I guess that does some. What does that do?
It's just going to create IAM identity mapping. So you're going to end up with a service account map to a specific role, I believe so. Oh, no, that's the one for, the role for provisioning instances, yeah.
Do you expect me to set my account? Oh yeah, I was about to say I should get that with STS, get caller identity, which I can. Hopefully just go there. Surely that could be an export before that then as well.
Yeah.
If you're going to do it down there. Probably these docs need a bit of an update.
Yeah. Oh, thanks a lot. Yeah, there is an example, getting started example with Terraform as well. So there was a question if you need to know CloudFormation. There is an example how to get started with Terraform as well. So you don't need to know CloudFormation.
Yeah. Which will be a bit quicker. Don't tell anyone.
Yeah, that's probably true. But yeah, that's just as we're going along, what we're creating now, it's literally the IAM roles needed to kind of provision the nodes as we're running the controller.
Yeah. So, I mean, before we had started, I'd already done that for the cluster API cluster as well. So there was a command called cluster AWS ADM. Information templates. It's a lot of the same things. Or you can just run create and it just does it for you. It's a lot of the same thing, except a bit more stuff because we're managing VPCs as well. All right, so that stack was created. We now need to do that. So is this because is this fiddling around with is this fiddling around with the AWS IAM authenticator stuff, or is it fiddling around with the OIDC stuff?
OIDC. So it's going to create a role with OIDC connection to EKS.
Right, let's do that export that bit because someone's got some time. Might be worth finding an issue for that one. Oh yeah, Justin just said the create IAM command modifies the AWS auth config map. Oh right, yeah, so it is with AWS IAM authenticator then. Yeah, that makes sense. We can. I guess we can just take a look at that config map after I've just run this. Why don't we take a look at it before and after? Okay, where is that config map? Is it in system?
AWS auth. Is it like that?
Yeah. Yeah. So for those who don't know, EKS uses a project called the AWS IAM Authenticator. It's what's used to have nodes join the cluster. It's also how authentication works. It's what allows you to authenticate using AWS credentials to the Kubernetes cluster itself. And it was that this was genuinely an old Heptio project, in fact, which we donated to the Kubernetes SIG. So it's going to edit this and add it. So it'll probably be clearer. Like I don't understand. I'm not completely familiar with the syntax. So I guess it will become clearer once I actually run it. And can anyone remember where I just ran? In this shell. Oh, what shell have I been using? Oh, Jesus. Yeah, this one. Sorry. Yeah. So that EC2 private DNS name. Is that? No, that's going to be templated. Okay. Yeah.
Yeah, that's going to be templated in the config map, but not here.
I see.
The variables
this makes
are
sense
AWS
now.
account ID and cluster name.
Yeah, so this will make sense now. So it's definitely not the OIDC thing. What we're saying is we're always. Hold on, we'll find out in a minute. So we're.
Have you exported the cluster name though?
I thought I did.
Okay, sure.
No cluster found. No, maybe not.
I think there is a suffix at the end of the amazing badger somewhere, isn't it?
Do I need to put the whole lot in?
Depends how the cluster is named, to be honest. I usually do specify that. I'm not sure what the default is if you try to leave it to the auto-generated name.
Yeah, except now I've created the stack with a different... okay, let's sort this out. So probably that is going to be Amazing Badger.
Okay.
Because that's the... but that cluster is going to be now this thing, I suppose.
You can always do get cluster using the eksctl. That should get you the name of the cluster that you created. So it's Amazing Badger with the suffix, yeah.
Okay, so this should work. And let's just check. Might just hide my screen temporarily, just in case. Right. I got a lot of output. There's a lot of so this is just a dev account, to be fair, but there's a load of additional garbage in this dev account for reasons. Yeah, that's fine. So I'll put my screen back. There we go. So we got that's that node role, blah blah blah. That's why we wanted the account ID. Right. And if we were to yeah, we can see the additional mapping. Yeah. Okay, cool.
Yeah. So the reason why this is created is when Karpenter is spinning up new nodes, they will be spun up using the Karpenter node role node profile that will have enough permissions to kind of join the cluster and kind of map the group in the IAM here. Sorry.
So is this something internal to its provisioner, or I'm gonna have to give this to Karpenter at some point then?
Yes, you need to provide this as a parameter when you're gonna run the controller or Helm chart or whatever you decide to use to provision it.
Yeah, that will make sense. So yeah, so what happens here is, for those who aren't familiar with if I remember this correctly, your +1 for kubps1, Vlad. Yes. I mean, I did used to run PowerShell as my default on Linux. I did do that for a while, but I got tired of missing autocomplete. Bash autocomplete. Is that what that is? Yeah. So the way this is work is we need a way to make sure not any old machine is joining your Kubernetes cluster, because that could be bad. So we spin up a machine with an IAM role. It's going to have some credentials from the instance metadata service. then to authenticate the Kubernetes cluster, it does, and it doesn't call AWS STS get caller identity, but it creates a signed request. So AWS uses AWS HMAC v4 as its signing mechanism for requests. It creates the signed request, sends that as the Kubernetes authentication token. There's a controller called the AWS IAM Authenticator, takes that, actually runs the execution and says, if that is successful, then I know that the person who gave that to me at least has this IAM role. They have credentials valid for this IAM role. And I'm now going to look it in my mapping. It then looks it in the config map and says, right, if someone comes in and they are able to present a sign request that matches this IAM role, then I will issue a service account token, which is a member of these groups, to bootstrap as a nodes group, with this identity. And this just happens to be exactly what is required for Kubelet to be able to register itself against the control plane. So that's how this is working. Right, so we got that. Next bit is whatever the Helm stuff. I've not used Helm for like a million years, so that's going to be fun. Right, we need to create so now we need to create an IAM role. Right, so now we're coming to the OIDC bit. We're going to create a service account for use with Karpenter. So Karpenter itself needs permissions to run EC2 run fleets and all those API calls. So we are now going to do that bit. And oh my god, come on, there we go, copy paste. And I don't trust any of my environment variables anymore. Well, AWS account ID is probably fine, but this one is the I should cancel that. Oh, what's going on with my prompt? This one's just amazing badger because I did it wrong.
Yeah.
Unhappy. Fine. Oh. Yeah, so earlier today, well, just before we started, I normally have the kube context stuff off on the spaceship prompt, but I was making so many mistakes, then it back on. Drawback is it's massively slows down just drawing of the prompt because it ends up contacting the cluster every time. Oh, how do I enable the okay. I need to enable. Do I need to turn on a plugin or what? How do I turn on the OADC stuff? Enable?
There is a parameter in the config when you use the EKS-Cuttle YAML file.
I'm going to have to kill the cluster, aren't I?
Maybe not. Let's try. Let me drop that here.
Yeah, because I did not use a config file. Yeah. SCPL set.
Oh, no, yeah. Not sure if it's part of the parameters. Should be, I guess.
If not, let me see if I can just turn it on in here. Right, we're in Ireland. No. All right, it's not there. Is it only at creation time then?
Just trying to quickly figure out.
Here we go. Oh, yeah, but so EKS CTL would have done a big dance to set this all up, and I haven't because I didn't do that. I would now have to do that manually, so I might be screwed. Because I'm not gonna. It's too late in the week to do the to do
Can
all
you
of
try
that.
running EKS Kotlin utils associate IAM OADC provider and cluster name?
Oh, that might be good. Yeah. Oh, okay, fine. Yeah.
Maybe that's gonna cut it. There is -- cluster name. Yeah.
And I put a dot at the end.
I think there's a approve that you need to provide as well.
Yes, that will do. Fine. We do not want to be doing that manually. Is that it? Is that it?
I think so.
Look.
Not sure if that's gonna appear here. I think those are the external providers, not the.
Are you sure?
I think so. Yeah. I think.
Oh yeah, there we go.
Yeah.
Got the overnight.
Yeah, that's the one. But the authentication is just for the external ones.
Just check that works. Okay.
Looks better.
Yeah, that's fine. Proteek said the error output you just got has the command for it. You mean this one or the one previously when I was? Okay, that does look better. Right.
Here we go.
Okay, so we got that. So for people not familiar with the OIDC stuff, so this is kind of based on bits which were introduced in Kubernetes 121, 120, I think. So Kubernetes, because OIDC is kind of being used in quite a few places, there was a support added to make Kubernetes act as an OIDC provider. And once you do that, there's the assume role with Web Identity Federation API in AWS, which allows you to exchange OIDC tokens for AWS credentials. So given that Kubernetes can act as an OIDC provider, we can make that Kubernetes cluster trusted for AWS, and then we can then have the ability to swap Kubernetes service account tokens for IAM role credentials. And then there is a webhook, which is called the, I forgot what the URSA stands for. Yeah, there's an EKS pod webhook identity thing that can take annotations of service accounts to exchange them for IAM roles, and that's kind of what this step is only necessary if this is the first time you're using EC2 Spot in this account. It very well might be. So, and also I keep nuking everything, so I will do that just in case.
Yeah, they're just going to create a linked row for Spot instances.
Yeah. I think I did all that previously, so I'm gonna Okay, so we now have this helm command that we're gonna whack in. I guess that should be the real one. So as in the one with the number.
Yep. That should match the real name of it. Yeah.
Rather than the service account, because that's already coming from the previous step. Oh.
Yeah, this one is just gonna do a query on the endpoint.
Thank you. Let's just check separately that works down here. No, it's not going to explode. Yeah, that's fine. Okay. Right, that's already running. Right, okay. So we have Karpenter running. Yay!
Yeah.
All right, after all that. So now we can run something. Did I install that? All right, so we have that prime numbers thing business running. How many nodes do I have right now anyway? Didn't even check. So I've got 2. Yeah, so I've got 1 node group. Oh yeah, so going back to what Don was saying, node group is EKS specific. Yeah, so yeah, so just machine deployments in cluster API, node groups in EKS, node pools in Cloud Foundry or old Tanzu Kubernetes grid integrated. Yeah, where everyone's got similar concepts to all that same. So we have 2. We've got the prime numbers. Oh, actually, what? I didn't even check. So it's m5.large. What is m5.large these days? I mean, no, EC2 instances.
Yeah.
Got info.
Good note, but should be a bit beefier than what you had before, I guess.
All right, it's frozen. What is M5N? I haven't seen that. Is that the Graviton ones? I thought that was M5G.
No, that's G. Not sure what the N is.
Oh, is it neural? Is it for neural? Is it?
No, all the M5 generation should already be having enabled that, but.
Oh, yeah, okay. 8. No, it's smaller actually. Smaller than the T3.x large. It's 8 gigs of RAM, 2 vCPU. So we have 2 of those. Right. So, okay. So if I were to edit that deployment, I guess.
Oh, it seems like the N stands for network optimized, so they can kind of handle up to 100 gig network performance. So.
Interesting. So, oh yeah, we were going to fake out the. All right, we're going to pretend that this needs, for mystery reasons, 10. Let's say 10. That's obviously too much now. Maybe let's have a look at the logs.
Yeah.
See what this is doing in the background.
Yeah, just the logs of the controller, yeah.
Nothing super exciting there. It's just saying it's reconciling nodes. Oh, work account 10. Let's have a look in here. Did I need to do anything else? Oh,
Yeah.
we might want to add. Oh, yeah, actually, hold on. Why don't we turn on the debugging? Why don't we do that?
That's gonna get very verbose, but okay. So what we're still missing is the
provisioner.
Yeah.
Interesting. Okay, cool.
So as you deployed Helm chart, that actually created a CRD for us, which we're gonna use here. And using that, you can actually define things like we mentioned before, what kind of instances you want to provision, which AZs you're limiting it to, and things like that.
All right, and we need to replace that. All right, I won't turn on the debugging then, as you're saying, it's so verbose. I'll leave it off. Fine.
I think it's going to be enough to see what we want to see not using the debug, but yeah, feel free to use the bug.
And then the instance profile has got the wrong name, so without the hyphen, so do that. So hopefully that. We want alpha 5. It's good. Good to see API.
Yeah, they want to use spot instances.
Do I want to use spot instances? I don't know.
Okay.
Do I don't know. Do I? Yeah, why not? Keeps the VMware accountants happy. I guess. They're not constantly asking me to reduce spend. It's fine. Don't worry. All right. Error.
Yeah.
Nice.
Have you labeled the subnets for the auto discovery? You haven't, probably.
I did not know.
Yeah.
I guess it would have done that had I used the config file to create the cluster, but given I didn't.
Correct. Yeah, I think the example provided in the getting started already has that in. So yeah.
All right, let's do that manually then. Obviously, don't do this in production. I've got a lot. There's a lot of subnets. Do I need to do it on all of them?
Private subnets where you want to provision your nodes.
Just a private subnet. So I can just pick one of these then. I don't have to do all of them, do I?
I think one is probably enough to get things going.
All right. So, what's it looking for?
Yeah, I think the cluster name is the value.
Yeah, that sounds about right. Let's have a look at this provisional resource. So it's got a status. Nothing. There's nothing in the status so far. Maybe I'll just give it a kick. Because it might have gone into back off or something. So I'm just gonna just give this a gentle kick.
Yeah. Yeah, let's do that. second. Looks a bit happier now.
Yeah, that's right.
Yeah, that's the status we're looking for. Okay. So it being packed one pod for a single node. Looks like
no security groups exist. Did I need to tag some security groups? Getting launch templates.
Yes, there are tags on those as well.
Oops. Is it the same ones or is it different ones?
Yes, it's the same tag that you use for VPC.
Fun. Okay. This one, I suppose. Yeah, so we could see the computed packing of one node for one pod with instance types, options, R3 large. So it's using some I think this information is, if I remember correctly, still compiled in, right? There's a table, lookup table inside.
So it's dynamically querying all the instance types available. Unless you specify like a list, you can kind of scope that down to a certain set of instances. But if you don't provide that, it's just going to consider all available instances that you can provision.
Still unhappy about the security groups.
Yeah, maybe it needs another kick in, to the controller. So if you scroll the way up, you're going to see, there is OIDC that we were missing, and there is stacks that are being kind of provisioned to all the resources.
Yeah, so it did say on this one. All right.
Oh, here we go.
Actually, yeah, maybe it's calmed down now.
Yeah. No, I think it needed some time to pick it up, but obviously there is a pod that has been bound to a node that has been provisioned. And if you look at the logs, you're going to see that it picked up R4 large. So that was kind of the optimal instance for the workload that we're looking for.
So does it, did it pick, I don't think it picked that. Did it pick that thing? No, or does it actually? What I thought it happened is it sends all of these into the fleet request.
No,
it definitely picks one.
It picks the one and provisions the specific one that it's provided here. Yeah.
Okay, maybe let's have a look at the fleets. What's it here?
At least, yeah. Should be EC2. Oh, no, fleet now.
Is it just all under EC2? Yeah, maybe it is. What is it? No. What?
I thought it was under EC2.
It's not under spot request, is it? Where the hell is it in the console? I see it. Justin.
Yeah, that was the one. So it was R4 large, yeah, the one that we provisioned. It might be a little bit different for spot rather than on demand, but I think with on demand, it will pick one up and provision on that one.
Yeah, I'm kind of interested. Why don't we just have a look at CloudTrail for a second and have a look at what it was doing? Actually, Right, so it sent a create fleet request, and in that request, it asked a spot. Yeah, it sends in all of them.
Right. Okay.
That's what I thought it happened.
So it just sends the whole list, and the fleet just picks one up, which is available.
Yeah, that's right. And then the response. So yeah, and then the fleet says this is the one that it picked.
Right.
Yes, because I've had this conversation with AWS in terms of like I can't remember it was with Ellis or someone else, but that in a sense, the run instance API is kind of deprecated-ish. Because with the run instance API, you can only request a single instance type.
Yes, that's true.
Whereas with the fleet API, you can send in all of them, and the fleet request will try and get the best one or the best cost one for you.
Yeah.
You can use EC2 instant fleet, which gives you the same outcome as EC2 run instance, but you can specify multiple instance types.
Right. So if you were to kind of specify a single one, the functionality is exactly the same, right? But you can provide multiple. Yeah.
Yeah. So you can. So AWS suggested that in Cluster API AWS that we actually rip out run instance, replace it completely with fleet. And I know there was some folk from Red Hat. I think Alice mentioned Michael McCune, but also I forget his name. Joe, someone. Oh my god, my memory is terrible. It's like go away from Cluster API for a week, and this is what happens. Yeah, so we have had some conversations about doing that in Cluster. It would be a migration because with people, we've got one set of IAM permissions, and they've been using that forever. And then we have to, if we switched API, we have to do a bunch of stuff to make that happen. But that is a way where we could at least enable the AWS. We could enable a Cluster API provisioner that works on AWS through, and Karpenter wouldn't need any permissions. And then we could start looking at how to support vSphere, for example. Like vSphere would be quite interesting, right? Because in vSphere, you basically have a slider, right? A moving slider for the amount of memory or CPU. So you could almost get a sort of Fargate type experience where you can provision a single node for that single pod, which has exactly the right CPU and exactly the right memory. It's quite interesting, which is something that VMware did in the past.
Right.
It was
that's interesting. Yeah.
So it's kind of interesting that old ideas come up again in new ways to enable new use cases, which is kind of interesting. Yeah, so what I'm interested in maybe is just having a quick glance at the.
So it's going to be AWS.
That's it. I did land on somebody else's repo or something. Right. So we have these cloud providers. So we have so have a provisioning. So we have the provisioner here. Yeah. Okay. And that provisioner resource, if you look at it, it's been written generically enough that it can, like, these are, nothing about this is AWS specific necessarily.
No, the section that's specific to the provider. Yeah. So the provider would probably react differently if you would have something like, I don't know, VMware or GKE or whatnot.
Yeah, because there's no instance profile in VMware Lab, for example, and no other cloud provider. So let's have a look in that. So what have we got in the spec? It's got provider type object.
So yeah, it's kind of prepared for different cloud providers, right? Currently, it only supports AWS, but should be able to extend that to like, VMware or Google or Azure.
Yeah, so that's kind of... Yeah, so I think that provider is kind of generic. So we'll just take as long as it's sort of valid JSON. So that could be anything. And then I guess that gets handed off then to this cloud provider. And we've got this AWS one. So if we were to want to write our own one, then we'd put the logic in here.
Yeah.
Which makes sense. Yeah. And I think some of this is cleaner then. Yeah, and as we said before, we're not importing the Kubernetes code, so that means we're not having to version together. Carlos says pod autopilot concept. What's that? What do you know what that is? Pod autopilot?
I'm assuming that's referencing the Google Autopilot, maybe? Yeah.
Oh, okay. Yes. Yes, very much so. Yeah. I think that would be definitely very similar in that regards.
Yes.
Yeah,
it does kind of offer the same functionality where you would just leave it up to the cloud provider to kind of dynamically scale up and down as you want, I guess.
Yeah. I think it's probably just to say everyone's clear. I had some conversation with some users earlier in this week. There are some limitations with Karpenter at the moment. I mean, it's a fairly early stage project, so still, I mean, it's GA from AWS perspective, but it's still an alpha API. There is still only one provider, the AWS one. But yeah, just be aware, like pod affinity, pod anti-affinity is not yet supported. So there are some limitations there.
I mean, the one that I kind of most commonly hear is, I think currently the node storage that is provisioned, it's kind of baked to 20 gig now. So the launch template that's used, it's actually having that predefined. Obviously, you can get around it by specifying a custom launch template, but it's currently not supported in the provider directly.
Oh, right.
Sorry,
okay.
provider provisioner, yeah.
Yeah, so that's interesting. So once you have so Karpenter will find it difficult to schedule because it doesn't support affinity or anti-affinity. So once you have that, so okay. So there are limitations, just be aware. The scheduler is not 100% complete today. And I think probably then this might need, if it's not in here, which probably might be worth making that clear in the documentation, probably. Like what are the limits? What are the limitations? What does work? What doesn't work? Just so it's clear to end users, I think. Because otherwise there's, just from my own sort of open source experience, if you don't make that clear, then people if you don't say what is possible, people will try and do things unexpectedly. And interestingly, EKS built-in core DNS leverages the pod anti-affinity rule. Yeah, so that's interesting. So there are some caveats that you need to be aware of.
Absolutely. I mean, obviously, if you look at the open issues, there are 117. So before maybe spinning that up in production, I would definitely recommend looking at those if those are the things that would block you or kind of prevent you doing stuff. Maybe hold it off for now. But
yeah, but it's definitely interesting and exciting. I think this is something to look forward to, and if there's also any chance of cross virtualization back to cluster autoscaler or otherwise, then that's also cool. We've been going for quite a while now.
Do we quickly want to try something really quickly, like what at least I found really a nice feature as well? So they do provide a finalizer on the node. So for example, if you go to the console and if you try to delete a node, it's interesting that it's actually having a finalizer on it, and it's actually trying to drain the node like gracefully, which is kind of a nice feature as well.
What if I just delete it from the console?
Yeah, just go kubectl, delete node.
Oh, I see.
Trash it. Yeah. I think that's a cool feature. So obviously, if there is capacity available, it will try to reschedule pods on a different node. But if there is not, it's just going to provision another node to satisfy the request. Just make sure you're killing the one that runs your workloads, but okay.
It's 13 minutes old, so I guess it was, and it's newer than other ones. So
I think you're right.
Yeah.
So maybe if you show the logs from the controller, we're gonna see what's actually happening.
Well, you know what would be funny if I killed the node running Karpenter.
Oh, that would be fun, yeah.
Didn't check that, did I? Oh, you got deleted. Okay. Cordon node. Okay, yeah, cool. So yeah. So that's similar functionality what we have in Cluster API as well. So in Cluster API, if you delete a machine, then it would start doing the same sort of thing. I guess the benefit of this is we get that bin packing quite quickly as well. That's pretty nice. All right, maybe we should call it a day. I think that's been going for an hour 50. I think that's good. Can let you go to sleep, and I can also. I mean, I've had multiple Monster energies, so I'm probably unfortunately not being able to sleep. But yeah, if you've let me be a normal YouTuber and say, if you've enjoyed the show, then click like. We're not sponsored. We don't get revenue from YouTube. None of that matters. But do click the like button. If you didn't like it, then leave a comment. Tell us what we can improve. And then also hit the subscribe button and click the little bell icon so you get notified every time we do a stream. Any final comments from you, Marco? Or?
No, I have to say I really enjoyed the session. Really, thank you for having me. It was great fun, kind of, doing it from the scratch. And maybe, like you said, you haven't really had an experience with it. So it was really nice to kind of get across all those bumps that maybe users would usually get across if they deploy it the first time around. So yeah, good stuff.
All right, thank you very much, Marco, for joining us, and thanks for everyone for tuning in. I think there is a show next week. Yes, there is. I forgot what the topic is, but we'll have another one. So see you next week, everyone.
Cool.
Bye.
See you. Bye.